Hello friends, welcome to Learners Forum. So under the conversion of number systems, let's see the last type, which is hexadecimal to octal and octal to hexadecimal conversion. So unlike the other conversions, this conversion is done in two steps. So we'll see the steps first and then we can solve the examples. So we have hexadecimal, binary and octal. So under these three types, we can convert any hexadecimal to binary directly, and we can convert binary to hexadecimal in a single step. Similarly, binary to octal and octal to binary can be done under single step, but to convert a hexadecimal to octal or from octal to hexadecimal, it cannot be done directly. So we need to follow the steps as per the cycle now. So hexadecimal has to be converted to binary, and from binary the equivalent octal value can be obtained by following the conversion. So that is how we can convert a hexadecimal to octal value. Similarly, to convert octal into an hexadecimal number, it should follow the reverse cycle, which is octal is converted to binary first and binary is converted to hexadecimal. So this is the procedure for this particular conversion. So hexadecimal to binary and binary to octal conversion is the first type, and octal to binary and binary to hexadecimal is for the second conversion. So in between we have to convert it in terms of binary, only then we can get the corresponding value. So this is the steps to be followed for this conversion. Let us solve an example so that we can understand it better. So the first example given is CAD, which is an hexadecimal number, and this has to be converted to its equivalent octal value, which is to the base 8. So to convert any hexadecimal to octal, we have to follow two steps as per the process. So first step is converting hexadecimal to binary and the second is binary to octal. So let us do the first step now, which is converting from hexadecimal to its binary value. So to convert hexadecimal to binary, that is from base 16 to base 2. So simply split out the given hexadecimal, which is CAD. So following the 8421 rule, we can write the value of C as 1100, for A it is 1010, for D it is 1101. If we know the value directly, you can write it, else you can use this 8421 technique. So before using the 8421, we need to know the value for what is CAD. So C under the hexadecimal from A to F, it is represented with 10, 11, 12, 13, 14 and 15. So C has a value of 12. So under 8421, 8 plus 4 is 12. So under that we have 1 and the remaining values are filled with zeros. So for C it is 1100. For A the value is 10. So 8 plus 2 is 10. Under that we can write the value of binary 1 and remaining 0. So for A it is represented as 1010. Next for D it is 13. So 8 plus 4 plus 1 is 13. So 1101. So this is the value of D. So to get the equivalent binary value, simply we can write it together, which is 1100, 1010 and 1101. So we have done the first step, which is converting an hexadecimal number into its equivalent binary number. The first step of hexadecimal to octal conversion is done using the binary in between. Now let us do the second step, which is converting binary into its octal number. So to convert a binary to its octal number, we have seen the conversion earlier. So the given binary number has to be split in 3 bits of each, starting from the rightmost bit to get its equivalent octal value. So the first set of 3 bit is starting from the rightmost value, it is 101. So that is written here. Next set of 3 bit is 101. So it is written. Next is 010, which is written here, and the last is 110. So that is written separately. So now this 3 bits has to be represented with its equivalent octal value. Using the 4221 technique, you can write the values. So for 101, the equivalent value in octal is 5, or you can use this 421 technique. So under 421, 101 in the sense we will have 4 and 1 alone. So 4 plus 1 is 5. Similarly, again for 101, we have the value as 5. Next for 010, which means under 2 we have binary 1. So the value is 2. Next for 110, so 4 plus 2 is 6. So the value of 110 is 6. So now we have got the equivalent octal value, which is 6255 to the base 8. So the given hexadecimal number is converted to its equivalent octal number. This is the procedure to follow for this conversion. Now let us solve one more example, which is CAFE to the base 16. First step is to convert the given hexadecimal to binary, which is to the base 2. So let us split out the hexadecimal value, which is CAFE. So the value of CAFE should be known, which is C is 12. So using this 8421 technique, let us represent the value of C in hexadecimal. C is 12, so 8 plus 4 is 12, so 1100 will be the equivalent value. Next for A, which is 10. So 8 plus 2 is 10. Under 8 and 2 we will have 1 and the remaining are 0. So 1010 will be the equivalent representation. Next for F, which is 15. So everything will be 1 because 8 plus 4 plus 2 plus 1 will be 15. So 4 ones will be the representation for F. Next for E, which is 14. 8 plus 4 is 12. 12 plus 2 is 14. So under 842 we will have 1 remaining 0. So 11110 will be the equivalent representation. Now the equivalent binary value will be 1100, 1010, 4 ones and 1110. This is the equivalent binary value for the given hexadecimal. Our procedure is not yet over. We have to convert this binary value into its equivalent octal value, that is convert base 2 to base 8. So to convert the binary to octal, segregate 3 bits of each starting from the rightmost value. So starting from the rightmost value, 3 bits will be 110, which is the first set. So we can write it 110. Next, the second set of 3 bits will be 111. So 111. Next set of 3 bits will be 011. Next set of 3 bits is 101. Next set will be 100. And the last single bit is 1. So fill it with zeros in front. So it is 001. Now we will write the equivalent representation in octal for this particular 3 bits of each value using the 4 to 1 technique. So using 4 to 1, the first value is 110. So under 4 and 2 we have 1. So 4 plus 2 is 6. Next for 111. So all are 1s. So 4 plus 2 plus 1 is 7. Next for 011. 2 plus 1 is 3. So we can write 3. Next for 101. It is 4 plus 1. So 5. Next for 100, it is 4. Next for 001, it is 1. So the equivalent octal value for the given hexadecimal is 14537 to the base 8. So this is the procedure to convert given hexadecimal number into its equivalent octal number. So the next conversion is converting an octal number into its equivalent hexadecimal number, that is base 8 to base 16. So for this conversion, again we need to follow 2 steps, which is converting octal to its equivalent binary first, and that binary is converted to its equivalent hexadecimal. So this is the procedure. Now let us solve an example following this technique. So the first conversion is octal to binary. So the given octal number 8 is converted to the base 2 value. So to convert octal to binary, first segregate the values which is given 652. So for this particular value, we need to write the equivalent binary. So using this 4 to 1 technique, let us write the values of 652. So for 2 it is Under 2 we will have binary 1 and remaining 0. So 0, 1, 0. Next for 5 it is 4 plus 1. So we will get 1, 0, 1 for 5. And for 6 it is 4 plus 2. So we will get the binary 1 under 4 and 2 and remaining 0. So 1, 1, 0. So the equivalent binary value for the given octal is 1, 1, 0, 1, 0, 1 and 0, 1, 0. Now this particular octal value is converted to binary value which is base 2. So our first step is over. So the second step is to convert this binary value into its hexadecimal value, that is to convert base 2 value into base 16. So to convert base 2 into base 16, we have to segregate starting from the rightmost value with 4 bits of each. So 1010 will be the first 4 bit. Next again the second set will be 1010 and only 1 is left. So we can take that and fill remaining 3 bits with 0 in front. So 0001 will be the bit. Now let us write the equivalent hexadecimal representation for this value using the 8421 technique. So 1010 means we have 1 under 8 and 2. So 8 plus 2 is 10. 10 is represented with letter A. Again 1010. So again we have the value as A. And 0001, which means we have just 1. So for the given octal value, the equivalent hexadecimal is 1AA to the base 16. So 652 is equal to 1AA to the base 16. So this is how we need to convert. Let us solve one more example. So this question was asked in TNEB AE exam under AAA. Find the hexadecimal equivalent for the given octal number 567.43 to the base 8. So this is of type 2, that is converting an octal number into its equivalent hexadecimal number. So octal should be converted to binary first and this binary has to be converted to hexadecimal. So let us follow this procedure and solve the problem. So to convert octal to binary, the given number is 567.43. So for each values in integer part and fractional part, using the 4 to 1 technique, let us write the 3-digit binary number for the octal value. So for 5 it is 4 plus 1, so 101. Next for 6 it is 4 plus 2, so 110. Next for 7 it is 4 plus 2 plus 1, so all the 3 bits will be 1, so 111. Next for 4 it is under 4 we will have binary 1 remaining zeros, so 100. Next for 3 it is 2 plus 1 is 3, under 2 and 1 and remaining 0, so 011. So the equivalent binary value can be represented by writing all the values together, which is 101, 110, 01, 110, 111, decimal point, and for the fractional part 100 and 011. So this is the equivalent binary value. 8 is converted to base 2. So the next conversion is converting base 2 to base 16. So 101, 110, 111, 0.100, 011 to the base 2 has to be converted to base 16. So for this conversion, for the integer part, starting from the rightmost value, we have to segregate into 4 bits of each. So the first set of 4 bits is 0111. So we can write it separately. And the next set of 4 bits is again 0111. And remaining we have only 1 bit. So 1 and followed by 3 zeros in front so that it does not make any difference. Decimal point. So for the fraction part, starting from the leftmost value, divided into 4 bits of each. So we have the first set as 1000, that is written. Next we have only 2 bits, which is 1 and 1. So refill the remaining with zeros. So we will have 1100. Now we have to write the equivalent representation for this particular 4 bits value so that we can get the equivalent hexadecimal value. So using the 8421 technique, we can find the equivalent value for these bits. So for 0001 under 8421, then we fill it up. We can see under 1 only we have the binary 1, so the value is 1. Next for 0111, 4 plus 2 is 6, 6 plus 1 is 7, so we have 7. Again 0111, so we have the value as 7. Decimal point. For 1000, we have 1 under the value of 8, so it is 8. Next for 1100, which is 8 plus 4, 12. 12 is represented with letter. In hexadecimal, from A to F, we have the equivalent value. A is 10, B is 11, C is 12. So we have 12 here, which means 1100 is represented with alphabet C. So the equivalent value is 177.8C to the base 16. So this is the equivalent value. So option 4 is our correct answer. So this is how we need to convert a hexadecimal to octal and octal to hexadecimal.